Okay, we'll go over the technical details of the AI model. I think this is if you're more interested in the details of artificial intelligence and machine learning. It's quite techy, so if you're just interested more in the results and investment theories, then you can skip this part. But it's quite interesting anyway. I'll try and sort of skip through some of the real major technical issues and sort of interpret some of these results that might be interesting to other people who are new to machine learning. So we use TensorFlow as our sort of model that ran our model. It's the technology created by Google, and we trained it over 50 epochs. Now this is basically 50 training session where it uses all the inputs, all the information that we feed into it. It runs 50 times, and it basically tries to improve each time. So we used a sequential model, and it was a regression-based type model. There's lots of different types of models you can do in AI. For this sort of thing, where you're predicting values, regression-based models, are most suitable. So our architecture comprised of 3 layers, and the first was a normalization layer, and this is just to make all the values that you're putting in into a sort of similar range, because the AI engine works better when the information is like that. Then followed by 2 dense layers. Now, dense sounds funny, it's as if it's not clever, but dense is really where all the artificial neurons are, the brain activity. So we put it through two brains, if you like, with a number of neurons in each, and we specify how many neurons we want to use. So this is actually just like human brains, going in, looking at the data, but really intensely, and doing many hundreds of thousands of calculations in order to try and work out patterns within the data. So we had 120 neurons in each layer, and it was quite a robust model, so it could learn from the data. Now we divided the data set, which this is commonly what you do, into a training set and validation set. So say if we've got 427 items, and ideally we'd like a lot more, but that's what we had. So what we do is we divide it, so we've got a number of training, and the AI model trains itself on that data. And then what we do is we put in the second part of the data to test it and see how it's performing. Okay, and that makes sense, because you don't just want it to train, on all the data and then it just gives its best guess. No, you have to actually see how it's performing against data which it hasn't seen and it hasn't used. So we're wanting performance improvements, training, and as well as the evaluation data. And by doing this, we did a number of different creative ways of improving performance, and we'll go into that. So we had 11 distinct types of inputs going into it. Elements like volume, cash flow, and price. We also had things like the market cap, where it was within the 3-year high, the price at the time, was it very low, had it been underperforming for a long time, or was it actually in an uptrend? So the model knew all of this. The model also knew broadly what sector it was in. For this model, we only split it into 2. We either said biotech or non-biotech. We didn't see too much of a difference between how it was working. As I said, we also had cash, but we also had the cash difference, the outflows of cash or the inflows of cash, and that was used as well. So this is something you see, this chart, when you train it. So you see steadily the loss goes down. Now that's a good thing. As well as with the validation set, the loss goes down. Okay, so what you can see is after about 25 epochs, it, improved a lot, and then the improvements were getting smaller and smaller. And after 50, we could see that although training loss kept going down, the validation loss started to go up, and that would have been a sign of overfitting. So this is how we know when to stop training it. And when we plot actually for our evaluation set all of our, predicted values against actual values. This is a lovely graph, I think, that really sort of shows you, where things are. Um, all these dots, if they're in short winners, then the algorithm would make you money. And all these dots, if they're in this long winners, then it would make you money too. And these are the ones, all these dots, that lose you money if you're shorting. And these are the dots that would lose you money if you're going long. So, as you can see, it really did a good job of identifying the short values. There was one that was out here, a bit of an outlier. And as you can see, is the P&L there is 1700. Minus 845 plus 1497. If you took all those four P&Ls and added them up, then that would give you, the return of what the model is providing. And that would be on an equal, position weight. So that shows you quite nicely how it provides it. As you can see with the longs, it's getting some of the longs that really are providing, a really nice return, and some of them that don't provide a return, the average is less. So yeah, you're going to get losers, but that's the way it works. You've got more winners and bigger winners. That's the whole plan of it. So don't expect that every position would go up, with this AI. No, we're looking at really overall return. So that's me taking you through just some of the technical aspects of the AI model.